Hello everyone, welcome to today's lecture. We are going to explore two essential Python libraries for data analysis. NumPy, numerical Python, which provides fast numerical arrays and mathematical functions. Pandas, which builds on NumPy and gives us series, 1D labeled data, and data frames like 2D labeled tables, like working with Excel in Python. To make this practical, we will analyze a real MBA dataset stored in Google Drive. Remember, we used this dataset in our previous examples, and I downloaded this dataset, MBA Player Stats 1998-2025 from Kaggle. So if you don't have this dataset, go ahead and download it from Kaggle. If you don't have an account in Kaggle, you probably need to create an account and download the data. So let's use that data. Since we are using Google Colab, the first step is to mount to mount Google Drive so we can access our dataset file. So here is how I mount Google Drive. Let me run this. So Drive is already mounted because I already mounted this Drive. So now that Drive is mounted, let's load the MBA data set into a Pandas DataFrame. A data frame is like a spreadsheet with rows and columns. So before that, let's import those two libraries. And here is how I load the dataset. I have already stored the data in a folder called Data Analytics, so you probably need to change this directory to find your own directory, and basically that is MBA file. Let me run this. So by doing so, I just loaded the MBA dataset into Pandas DataFrame. So whenever we load a dataset, the first thing we do is explore it. So there are many ways to explore the data. The first one is probably getting the shape of the data. So shape tells us the number of rows and columns. Let me run this. There are about 13,000 rows and 3 columns in this dataset. Head tells us about the first 5 rows. So basically this is the first 5 rows in my dataset. If you are interested in more rows, so basically you can provide a number and you can get like how many rows that you would like to get. So basically here, when I changed it to 12, I get 12 rows and 30 columns. You can also do tail to get the last 5 rows, like basically print DataFrame tail, and this is the last 5 rows. So basically you see that these are the index for the last 5 rows. If you are interested in other numbers, you can just provide it and get, for example, 10 last rows in your dataset. You can also do like info, which tells us the data types and missing values. So let me run this. So basically it provides information about the title of the columns, missing values, data types, so on and so forth. Next, we will use describe to get the descriptive statistics of the variables, actually just numerical columns. So this will quickly get average, minimums, maximums, and other statistics for all numerical columns. So you see that, for example, for the variable age, this is the mean value, standard deviation, minimum value, 25 percentile, 25% percentile, 50% percentile, 75% percentile, and maximum. And basically it applies to all other numerical variables. Sometimes we only care about specific columns. For example, let's look at player names, points, and assists. So DataFrame player points and assists. And let's get the first 5 rows. So basically we only get those 3 columns that we are interested in here. There is also another concept like filtering, and filtering allows us to select only rows that meet certain conditions. For example, we can find all players who scored more than 20 points per game, or find players under age 23 who scored more than 15 points. So basically the first one is about the players who scored more than 20 points per game, and we are only interested in those 3 columns: player, points, and year, and just the first 5 rows. And the second one tells us about the players who are aged under 23 and scored more than 15 points. And again, we are interested, let's say, in these columns for that. Let me run this, and basically you can get the results here. I actually need to copy this into another code cell. Let me remove this one. So basically these are the results for this command, and this is the result for basically this one. So this shows basically those players who are under 23 years old and scored more than 15 points. And we are only interested in those 4 columns: player name, as you see, this is the player name, age points, and year. And you can expand the table actually to see that as well. Sometimes we want to calculate new metrics. A common one in basketball is points per 36 minutes, which adjusts scoring for playing time. We will add it as a new column and then show how to remove it. So basically here we are interested in those points per 38 minutes. We are defining a new column, and this is how we define that: points per 36 minutes, 36 minutes, and we get the results for that, and we drop the column. Datasets often have missing values, so we can check how many values are missing, replace them with a default value, for example 0 for 3-point percentage if a player didn't attempt a shot. So this is how it works. Print is null. So by doing so, we check how many values are missing first, then replace them with a default value, which is 0 here. This is the default value that we define for this variable, for the missing values in this variable, and basically they replace them with a default value. Sorting and ranking is another topic when we deal with datasets. Sorting lets us rank players. For example, we can sort the dataset by points to find the top scorers. So this is how we do sorting in Python, and basically we do the sorting by points, and let me run this, and it does the sorting for us. And here see that I am only interested in the top 10. You can do, for example, top 15, and it will show you the top 15 players in your list. And here I am just telling that I am interested in those three columns as we had in the previous example: player, points, and year. And let me do actually 20 column, 20 rows, and these are the top 20 players of the NBA history. Now topic is about grouping and aggregation. We can group the dataset by categories and calculate statistics. For example, average points per team or average age by position. So the first one tells you the average points. This will give you the average points per team, and basically, and the second part kind of sorts that, and this one gives you the average age. This is the average age, mean of age by position. So basically you have the average age for different positions in your data set. Again, here you can define like this was for the average points per team, and we sorted that using sort values, and basically from the highest average to the lowest average, and we only get the top 5. We can try to get the top 10 here, or let's say top 20 here. So those are the top 20 teams based on average points. The next topic that I am going to talk about is correlation analysis. Correlation tells us how strongly two stats are related. For example, do players who score more also assist or rebound more? So for this data frame, I will use points and assists and what else? And I'm interested in correlation. So let's do correlation. So this will give us the correlation between those variables, those columns, and we are interested in exploring to see if players who score more also assist or rebound more. So basically it shows you the correlation between those variables. So Pandas offers much more. Here are some extra challenges you can try. For example, value counts, which teams which team appears most in dataset. So this is the value counts, and we do that based on team, and we get the top 10. So those are the teams that appear most in dataset. You can also see how many unique teams and positions are there. So this will show you how many unique teams and unique positions are there. You can also explore other things like average points by team and position. So using a pivot table, so this will show you the average points by team and position. So there are also many more in exploring and cleaning data. But today we learned how to mount Google Drive and load a dataset into Colab. We learned how to explore the dataset with shape, head, tail, info, and describe. And basically we learned how to select and filter data, add or remove and transform columns, handle missing values, what else, sorting, grouping, and aggregating, check correlations, and yeah, that's it. And I gave you advanced tasks like pivot tables and some others. Thank you very much for watching this video. If you found that interesting, please like and share and subscribe, and I will see you in the next video.